Here is a brief description of it based on the rich semantic information contained in Chinese word vector. This project applied Chinese word vector to the task of assessing the severity of aphasia. In this project, we conducted the study for Cantonese aphasia patients and Mandarin patients, respectively, and used Chinese word vector to model the phonetic transcripts of aphasia patients and normal people in the story description task, and compare the difference in the performance of the two in the story description task, so as to evaluate the disease severity of aphasia patients. Now I am going to introduce the data. There are two groups of training data were obtained from descriptions of the same illustrations by normal people and aphasia patients, respectively. There are 7 illustrations, 118 normal subjects and 92 aphasia patients. Each of 210 people describes the 7 illustrations in 7 paragraphs. For example, in the picture above, a boy kicks a ball and breaks a window. The man inside sees him and looks out. For the text data in the ID column, the C101M is the identity of the person ID, and S01 is the ID of first story, which means the C101M person's description of first story. The context column has the content of description. A total of 118 multiply 7 paragraphs of description of normal people, and 92 multiply 7 paragraphs of description of aphasia patients were obtained. In addition, evaluation data for the symptoms of these 92 aphasia patients are shown in the table below. ID is consistent with the ID of aphasia patients in the training data. AQ, which is aphasia quotient, is aphasia used to evaluate the grades of aphasia patients. The smaller the value is, the more serious the aphasia patients are. Now comes to the tools I'm going to use in this project. First, I'm going to use Java, because the English dataset itself is composed of single words as most fine-grained text, so there is no need for word segmentation. However, Chinese text is most fine-grained words. The basic unit of semantic expression is single or multiple words, so Chinese word segmentation is needed. And Word2Vec is another tool that I use in the project, which is also the main tool I used in this project. Word2Vec is a correlation model for generating word vectors. These models are shallow two-layer neural network trained to construct linguistic word text. So far, I have learned the basic usage of Word2Vec on some simple text. Here is the result of Word2Vec after training. We can use a vector to represent each word. It can be seen that in English words, dogs are similar to other animals, such as cat, cow, goat, and something else. In analogy, such words can be obtained by adding and subtracting word vectors, such as father plus woman minus man is equal to mother, which is the same in Chinese words. Since the original vector was 100 dimensions, it was difficult to intuitively understand, so I used TNSE to reduce the vector to 2 dimensions. It can be seen from the scatter diagram that the effect is good even if the vector is reduced to 2 dimensions. For example, the word 8 days are marked in one red circle, and for words but and however, they are marked in another red circle. In the future, I would like to find a way to use the vector to represent the severity of aphasia patients. For now, I plan to compare the vector of aphasia and vector of normal people, describing the same stories and calculate the cosine similarity of them. Thanks you.